Welcome to this how-to session on using the Object REST API with Azure NetApp Files. My name is Ashutosh Panda and I am a technical marketing engineer for Azure NetApp Files. I am joined by my colleague Thomas Willingham, who is also part of our technical marketing engineering team. In this session, we will walk through the entire end-to-end flow from preparing your Azure NetApp Files environment and generating the necessary certificate to creating buckets, exploring data, and finally validating access using an S3 compatible browser. Here's what we will cover. Review Azure NetApp Files, prerequisites, and volume creation. Generate and upload a certificate using Azure Key Vault. Create a bucket on Azure NetApp Files volume. Create additional buckets with different UID GID values. View enterprise data already available on the volume. Configure an S3 compatible browser to validate bucket access. Before we get started with creating the bucket, there is one prerequisite we must complete first. We need to generate the certificate, download it, and keep it handy because we will upload it in next step during the bucket creation. In this video, I'm going to use Azure Key Vault for generating the certificate. Open Azure Key Vault and choose Generate Import Certificate. The first field you will see determines how the certificate will be created. For our scenario, select Generate. This creates a brand new certificate directly inside Key Vault so it can later be exported. Select the certificate authority. Type of the certificate authority CA. For this demo, we will choose self-signed, which you can use for POCs and environment demos. This works because Azure NetApp Files Object REST API supports certificates where the issuing CA and the FQDN align. You can use external CA if your security policy requires it. Define the subject name CN. This is one of the most important fields. Set the CN to the volume IP or CN to the FQDN. For this demo, we are using volume IP. Use whichever endpoint you wanted to use for the bucket access. If you will be calling the bucket using the volume IP, then set the CN to the volume IP. If you want to use the custom FQDN, set the CN to the name. This must match the FQDN field you upload during the bucket creation. If they don't match, the browser or the S3 client will reject the certificate. Define the DNS name, subject alternative name. DNS name here, again provide either the volume IP or the FQDN. For this demo, I am using volume IP. This acts as a subject alternative name. It ensures client can validate the certificate against the endpoint they are connecting to. Here is the tip. Always keep the CN and the DNS name consistent with the actual API endpoint used in the S3 clients. Set the validity period that defines how long the certificate will remain valid. The common choices are 12 months for the production, 6 months for the dev test. For this video demo, the defaults are fine, but shorter validity cycles improve security hygiene. Choose the content type. Select based on your requirement. This is required because the Azure NetApp Files expects .pem certificates or PFX certificates or CRT certificate bundle containing the public certificate and the chain. Configure the lifetime actions. Here, the Key Vault allows automated certificate maintenance. Set action automatically renew to lifetime of 85%, which is a default value. This means Key Vault will automatically renew the certificate when 85% of its lifetime has passed, ensuring your Object REST API endpoint never breaks due to the certificate expiry. Now generate and download after configuring these fields. Click Create. Wait for the certificate status to show completed. Go to the certificate, download, select format. This is the file you will upload back into the bucket creation page in Azure NetApp Files. Once you upload it, the API endpoint is now secured and you can continue with the creating access key and secret key for your bucket using the certificate when you create your bucket. In this section, we will walk through the process of creating a bucket on Azure NetApp Files volume using Object REST API. Let's look at each field you will encounter and understand what it means. The first field is the bucket name. This is simply the identifier of your bucket. It should be unique and easy to recognize, since you will use it in API calls to reference the container. Next is the path. This defines the directory within the Azure NetApp Files volume where the bucket is mapped. By default, you may see multiple buckets using the same root path, represented as /. While this is allowed, it means those buckets overlap in the same directory, which can be confusing. To keep the data organized, you can specify other names such as /project A or /data. This creates a logical namespace under the volume and helps separate content. The following fields are UID and GID. The user ID and the group ID. These values determines the ownership of the objects created in the bucket. Assigning different UID and GID values allows you to control which users or applications have access. For example, one bucket might be tied to a specific application's service account, while another is owned by a different team. This ensures proper isolation and permission enforcement. If your goal is to enforce different access policies for different teams or applications, using the same UID or GID won't achieve that. Everyone with that identity can read, write across all those buckets. Permission defines what operations are allowed. A read-only bucket restricts uploads and deletion, while the read-write access enables full object operations. Choose carefully based on how the bucket will be used. Finally, the certificate management secures your API endpoint. You will provide the fully qualified domain name here or the FQDN and upload a PEM file or PFX file based on your requirement containing the certificate. This ensures that all communication with the bucket is encrypted and authenticated. Now let's see how to create multiple buckets on the same volume. Click Add Bucket, then provide the required fields, name, path, UID and GID, and choose whether permissions are read-only or read-write. Save it and your additional bucket is ready. In this demo, I used the root directory of the volume, therefore I specified /. You can also use a subdirectory like /test if you want to create bucket under a specific path. For example, I have assigned different UID and GID values for the additional buckets to demonstrate multi-tenant isolation. With the buckets created, let's look at the enterprise level data already on the volume. In this demo, the volume is mounted on a Linux VM over NFS mount point. A ls command shows the listed files stored on the volume. Next, we will configure an S3 compatible browser to validate bucket access. Step 1. Install the root certificate. Open a browser HTTPS URL using the bucket's FQDN or volume IP. Click the certificate icon, export the root certificate and install it. Here, I have used a normal browser to complete the certificate import. Set up the S3 browser, download and install the S3 browser. Choose S3 compatible browser. Set a display name, your bucket name. Select S3 compatible storage as the account type. Provide the API endpoint using HTTPS plus FQDN or HTTPS plus volume IP. Enter the access key and secret key created earlier. Save the configuration. Refresh the S3 browser and your bucket appears. You can finally verify the objects inside it. Notice this is the same data as the data accessed on the Linux VM using NFS. This confirms successful Object REST API setup and the S3 compatible access. Thank you for watching. Visit the Microsoft Learn page or scan the QR code below for more details.